Did you know that the deepest parts of the universe and the ocean share many surprising similarities? Venture with us into the abyss where darkness reigns supreme, both in the cosmic void and the ocean's depths. What deadly secrets do these silent, shadowy frontiers hold in common? Stay tuned until the end to uncover the mysteries that bind the vast universe to the enigmatic sea. Let's dive in. Space and the deep sea are both extremely cold and dark places where humans cannot survive without special equipment. The intense pressure in these environments can be deadly. Gravity behaves differently there, which can make explorers feel weightless. To explore these areas, one must be able to float or move through water or space easily. Both the universe and the ocean are full of mysteries and amazing discoveries waiting to be made. The ocean's depths are home to ancient relics and unknown species, while the far reaches of space hold secrets yet to be revealed. Now, let's explore the events leading up to the founding of NASA. The year was 1957. The Journal of the Royal Society of Arts published a paper stating that the deep sea covered more than 2/3 of Earth's surface. Yet, our understanding of the deep sea's topography was not as advanced as that of the moon's surface. Before the advent of echo-sounding technology to map the seafloor, humans knew very little about the seabed's topography. Since then, we have made significant progress covering 23.4% of the seafloor. While we use satellites and telescopes to map the moon, we have only completed a high-resolution map of 120 million square kilometers of the seafloor. That's about 3 times the surface area of the moon, rendering some previous statements inaccurate. Now, our focus turns to Mars, which has a surface area of 144.5 million square kilometers. However, our understanding of our own planet still has major deficiencies. NASA was established in 1958 with the mission to broaden our understanding of the atmosphere and outer space, and to advance and disseminate related technologies. Initially, ocean exploration was not part of NASA's plan. However, by 1978, NASA launched its first ocean monitoring mission with the Seasat satellite, which could measure sea surface wind speed, temperature, wave height, and other oceanic characteristics. This significantly improved our understanding of the oceans and their influence on global climate. Yet, it wasn't until the turn of the century that NASA began some of its most innovative work regarding the oceans. The ocean provided astronauts with a way to simulate the conditions of space, preparing them for space exploration. Located about 8.7 kilometers off the coast of Florida, USA, is the world's only undersea research station, Aquarius Reef Base, established in 1986. This small facility, with a 37 square meter main room and sleeping area, can accommodate 6 people at a time and integrates the entrance, dock, and access to the surrounding sea. Aquarius was designed to utilize saturation diving techniques, allowing divers to work continuously on the seabed at a depth of 19 meters. In this state, the gases in human blood reach a saturation point, enabling researchers to stay underwater for extended periods without the usual dive time limitations, which are typically 1 to 2 hours, extended to 9 hours. This makes Aquarius an ideal location for studying the undersea environment. By 2001, NASA, along with the European Space Agency and other space agencies, recognized that Aquarius was also an ideal site for space training. Astronauts could spend a week living and working under conditions similar to those on the International Space Station, giving them the opportunity to conduct scientific experiments and learn to handle both expected and unexpected situations in challenging environments. NASA then launched the NEMO, NASA Extreme Environment Mission Operations, project, sending astronauts to this undersea habitat for training. Since its inception, the NEMO project has completed 23 missions, each lasting up to 3 weeks, with astronauts from various space agencies participating. There, astronauts become divers, experiencing deep-sea conditions analogous to space travel. This training is paving the way for humanity's return to the moon or even future missions to Mars. We stand on the brink of a stellar mission, poised to unravel the mysteries not just above but also beneath. NASA's ventures into the oceans serve a purpose far greater than training its astronauts. They are a prelude to the exploration of extraterrestrial seas. Our spacecraft have revealed that Earth is not alone in harboring oceans. Jupiter's moon Europa and Saturn's moon Enceladus both conceal vast oceans beneath their icy crusts. Despite Europa's diameter being only a quarter of Earth's, it is believed to hold twice the volume of all Earth's oceans combined. This shadowy aquatic realm, devoid of direct sunlight, where liquid water meets rocky seabed, may be the cradle for extraterrestrial life. Scientists are devising methods to probe these alien oceans. Is life thriving in these frigid depths? NASA's ambitious plan involves launching a mission to Europa by 2040. The Europa Clipper will soar above the Jovian moon, scanning its icy shell to deduce the ocean's composition and understand the moon's overall state. Yet, the Europa Clipper's mission is merely a stepping stone for more audacious explorations to come. In the future, nuclear-powered ice melters and cryogenic robots could bore through up to 10 kilometers of ice, offering us a first-hand glimpse into Europa's hidden oceanic expanse. Once these robotic explorers reach their destination, they will survey the environment beneath the ice, potentially unveiling secrets that could redefine our place in the cosmos. Radio signals face a formidable challenge when attempting to penetrate layers of ice, necessitating the transmission of data through the accompaniment of a colossal diving robot, tethered by substantial cables. These cryogenic machines must possess the capability to autonomously navigate the abyssal darkness, enduring the bone-chilling cold and the crushing pressures found at depths ranging from 10 to 20 kilometers, all in pursuit of potential extraterrestrial life forms. Earth's own largely unexplored oceans serve as the perfect proving grounds for such ambitious missions. NASA's utilization of the oceans extends beyond astronaut training. It is a critical component in preparing for the exploration of alien oceans. Our spacecraft have unveiled that Earth is not the only celestial body with vast bodies of water. Jupiter's moon Europa and Saturn's moon Enceladus both harbor extensive oceans beneath their thick icy crusts. Despite Europa's diameter being merely a quarter of Earth's, it is believed to contain double the volume of all Earth's oceans combined. These dark aquatic realms, shielded from sunlight, where liquid water interfaces with the rocky crust, may provide the ideal conditions for life to flourish. Scientists are actively developing methodologies to investigate these alien oceans. Is there life thriving within these frigid depths? NASA's ambitious plans include the launch of a mission to Europa by the year 2040. The Europa Clipper will orbit the Jovian moon, meticulously scanning its icy shell to ascertain the composition of the ocean beneath, thereby enhancing our comprehension of the moon's overall condition. However, the Europa Clipper's mission is merely laying the groundwork for even more daring exploratory endeavors that may follow. Future missions could deploy nuclear-powered ice melters and cryogenic robots capable of boring through up to 10 kilometers of ice, providing us with an unprecedented view into Europa's concealed oceanic expanse. Upon reaching their destination, these robotic explorers will survey the environment beneath the ice, potentially revealing secrets that could redefine our understanding of life in the cosmos. Because radio signals cannot easily penetrate through ice, the information must be relayed via a large robot that dives in tandem, connected by substantial cables. These cryogenic machines need to be capable of operating autonomously at depths of 10 to 20 kilometers, in the dark, cold, and high-pressure environment, exploring for possible signs of alien life. As they probe the deep sea, they search for life forms never before seen, driven by an urgent mission objective. What better starting point could there be than Earth's own unexplored oceans? The deepest part of our ocean, the Mariana Trench, reaches depths of over 11 kilometers. The difference in Earth's gravity makes the pressure comparable to what would be felt hundreds of kilometers within Europa. The ocean is thought to be 130 to 260 miles deep, with a net water pressure of 0 MPa, equivalent to the largest ocean pressure at about 13 to 26 kilometers deep. Although this is easier than traveling 10 kilometers on Earth, it remains a very challenging task. The Mariana Trench, the deepest point in Earth's ocean, experiences pressures 10 times that of sea level, strong enough to crush individual cells in the human body or most submarine structures. However, despite such harsh conditions, life not only survives but thrives here. The 1977 Galapagos thermal vent expedition showed that deep-sea explorers, using specially reinforced ROVs, could delve into these extreme pressure environments. They were surprised to find that these places were not desolate wastelands, but rather bustling ecosystems around thermal vents on the seafloor, teeming with tube worms, crabs, and fish. As scientists conducted more dives, they discovered all kinds of strange creatures in these deep-sea environments, including palm-sized amphipods like Alicella and the 8-meter-long ethereal giant squid. These creatures, resembling alien life forms, are found in the deep-sea zone known as the Hadal Zone, named after the god of the underworld. Life has learned to adapt in unimaginable ways in this zone, demonstrating amazing adaptability that allows scientists to better speculate about possible life forms on other planets. The deepest parts of the ocean are usually located near the fault lines of continental plates, where one plate subducts beneath another, creating a unique V-shaped environment that funnels organic debris from above. Whenever a carcass sinks into these abyssal depths, scavengers quickly detect it and converge within minutes. In addition, other organisms rely on the nutrient-rich plumes that burst from thermal vents. NASA plans to use unmanned submarines to explore these extreme environments, such as thermal vents in Earth's deep oceans. These unmanned submarines will be equipped with cameras and AI that can map terrain similar to the technology used by the Curiosity rover on Mars. The total area of all these trenches on Earth is equivalent to an entire undeveloped continent the size of Australia, offering a new frontier for exploration and discovery. Embarking on the formidable task of deep-sea exploration, submarines must be engineered to endure not only the immense pressure of the ocean depths but also the extreme temperatures of hydrothermal vents, which can soar to hundreds of degrees. In 2014, an unmanned deep-sea craft named Nereus was launched into the Kermadec Trench off New Zealand's coast. Despite previous successful dives, Nereus could not withstand the trench's extreme pressures and imploded, its remnants later found floating on the ocean's surface. In response to Nereus's fate, NASA developed a smaller, more agile autonomous submarine named Orpheus. Currently undergoing tests in shallower waters, Orpheus's trials aim to confirm its performance and resilience under pressure. If successful, Orpheus's compact design could facilitate its transport to the depths of the ocean, perhaps even by rocket to the distant sea of Europa for exploration. At Caltech's NASA Planetary Exploration Division Academic Technology Office, PESTO, a diverse team of 40 students and leading researchers convened to address the practical, technical challenges of deep-sea exploration. They determined that such missions are not only scientifically feasible but also compelling, potentially offering the most logical means of discovering extraterrestrial life, akin to what might exist in Europa's ocean. The comprehensive data collected by the Clipper and Orpheus, along with other technical experiments conducted by autonomous submarines, suggest that witnessing this dream become a reality within our lifetime is possible. Although no specific plans are currently in place for a man-made unmanned submarine to traverse the dark expanse of space, the prospect of what it might encounter as it navigates alien oceans is tantalizing. The exploration could evoke a sense of familiarity, for we are water-based beings, and the first complex organisms on Earth originated in our oceans. All life as we know it relies on water. Thus, exploring the oceans beyond our planet may yield discoveries more profound than those found in dry, dusty wastelands. The enigma of what lies within distant alien oceans remains, but the mere possibility of life existing elsewhere in our solar system is thrilling. The discovery of life beyond Earth would have significant implications, suggesting that life might be a common occurrence across the universe. We must be prepared to encounter diverse life forms, a challenge that compels us to continually advance our planetary technology. Only then can we penetrate the icy shells of distant worlds and uncover the answers we seek. NASA's quest for life in the solar system begins not in the far reaches of space but within our own planet's oceans, where the search for the unknown continues to inspire and drive our explorations. If you liked this, give this video a thumbs up and subscribe for more Eureka Science Sauce videos. Thanks for watching.